Alright, this is project 2, and what we're going to be doing is working with algebra tiles. We're going to do some addition, subtraction, multiplication. We're going to solve for single variables, and we're going to do some modeling, okay, of adding, multiplying, and dividing polynomials. Okay, so to get started, let's take a look at the algebra tiles that we're going to be using. We're going to start with the simple concept of one of these little squares representing 1 unit. Okay, and so our width and our length of it is only 1 unit, so it's just 1 square unit. All right, when we see the yellow, that's going to be a positive unit, or a positive 1, and when we see the red, that's going to be a negative 1. Okay, for our x's are also the same length or width as 1 unit, but we have some unspecified length on it. That unspecified length is a length x with the width of 1, and so each of these bars is going to represent 1x, whereas each of these only represents our 1 by 1 unit. And because x is so long, when we have x squared, we're going to represent with this large square, okay, because it is x by x units long. So this is going to be x squared. These are just x, and the area of these are 1. Okay, so getting to the units. Simple addition and subtraction using the algebra tiles. Okay, we're going to take a look at just the concept of 2 plus 4. Okay, so looking at 2 plus 4, alright, to most of us, okay, we know the answer, but using the tiles, all it is a counting principle. All we have to do is take those 2 tiles and add them onto the 4 tiles that I already have, and then just have the student count the number of tiles that they have, so they can see that the addition of 2 plus 4 is equal to 6. Okay, the same thing would work if we did something like 5 plus 3. So if we were trying to add 5 plus 3, of course it would be a similar thing where we would just take the 5 tiles and add them to the 3 tiles, which would give us a total of 8 tiles. Okay, so this is one concept that the students could learn just by joining the tiles together and then counting how many tiles they have when the 2 are joined. Now, a problem for the students may arise when we start adding with negative numbers. So let's say we take negative 4 plus 3. So if we were to add negative 4 plus 3, how would the student do this? Because clearly they're not going to have the same color tile when they finish. They're not all going to be positive tiles. Okay, so what we can do though is we can match up these positive tiles with the negative tiles that we have. And this introduces the concept of 0. If I have a positive 1 and a negative 1, those are going to cancel out. And so we can do that with each set of tiles that we have, to where all we're left with is a negative 1. So clearly negative 4 plus 3 equals negative 1. Okay? We can use this for subtraction as well. So let's say we have 6 and what we want to do is subtract 3. Okay? So a couple of ways that we could do this. One would be just to simply take away 3 positive tiles. Another way to think of it is 6 plus a negative 3. Okay? Because those terms are going to be the same. So some students may get the concept of 6 take away 3, in which case we do that and it leaves them with the 3 positive tiles. Okay, but you probably want to introduce them to the concept also of 6 plus negative 3, in which case we would again match these tiles and then take away all of the zeros, because that would be 0, that would be 0, and that would be 0. And either way we work it, we are left with only 3 tiles remaining. Okay? Now another one would be adding, or actually subtracting 2 negatives. So let's say we had negative 1 minus negative 3. Okay? So if we had negative 1, okay, we could think of this as negative 1 minus negative 3, but now how do you take away something that's already like that? Okay? This is a problem that the students are going to have. They're really not going to understand, possibly the first time it's introduced, negative 1 take away negative 3. Okay? But what I use with the students is to say, okay, what this really is that if you see double negatives, if you see that we're subtracting a number that's negative, then it's going to be the same as negative 1 plus 3. In which case, they could set up their tiles like this. And then again, we would match, and we would take away all the 0 pairs, and we're just left with positive 2. Okay, now we're going to look at some multiplication and division. So what we have is just 3 times 5, and we want to know what 3 times 5 is equal to. So you tell the students that 3 times 5 is the same as taking 3 groups of 5 tiles apiece. Okay? Now if we're combining 3 groups of 5 tiles apiece, then really all we're going to be doing is just counting how many tiles we have. So they could take the tiles and put them together. And then count how many tiles they have. So 3 times 5 would just be 2, 4, 6, 8, 10, 12, 14, and 1. And so we can use the tiles to show that 3 groups of 5 will be 15. Okay? Now what if we want to do multiplication with a negative number? Let's say 3 times negative 2. Well, it would be very similar. In this instance, we would have 3 groups of 2 tiles, and these 2 tiles would be negative. Okay, so multiplication of a positive times a negative is going to work much the same way. So if I have 3 times negative 2, I just set up 3 groups of negative 2 tiles, since each of these represents 1, and again put them together and count the number of tiles that I have after I combine my 3 groups of negative 2. So I have negative 2, negative 4, and negative 6. Okay, we can also do this with negative numbers times another negative number. Okay, let's say negative 2 times negative 4. Okay, now this one's going to be a little bit trickier, but the way that we're going to show it is by saying that we are starting from 0 and we are taking away 2 groups of negative 4. Okay, so again, when we have a positive and a negative together, we already established with the students that this is equal to 0. And so right now we're looking at 0, and what we're going to do is just take away, or negative 2 groups of negative 4. So I take away the 2 groups of negative 4, and what I'm left with is 8. So by starting from 0 and taking away 2 groups of negative 4, I get positive 8. Okay, last we're going to look at division. So we're going to figure out what 12 divided by 3 is. So we would start out with our 12 tiles and tell the students that we want to divide these 12 tiles into 3 equal groups. Okay, well, since we have 3 columns, that makes it fairly easy. We'd be able to take the groups of tiles and separate them so that we had 1, 2, 3 groups. And then we just ask the student to count how many of the tiles are in each group. So you can look at this and say we have 4 tiles in each group. So if I divide 12 evenly into 3 parts, my answer would be 4. Okay, we established at the beginning of the video the tiles that we were going to be using for 1s, the tiles we were using for x, and the tiles that we were using for x squared, which was the larger square. So now what we're going to do is show how would you model a function, a linear function or quadratic function, using the tiles. So I'm going to start with something real easy like 2x squared plus 3. Or let's make it 2x squared minus x plus 3, so we can use all of them. Okay? So like we said before, these are our x squared tiles. That would be negative, this would be positive. Well, because we have positive 2x squared, we want to use 2 positive x squared tiles. Now our x's were the thin rectangles, and because it's minus x, we could show it like this, as just negative x. And then our last thing is going to be plus 3. And so we could show 2x squared minus x plus 3 this way, using our algebra tiles. Okay? Now if we wanted to combine and let's say do some addition with this, well, let's change this and say 2x squared plus 3 plus x squared plus 2x plus 5. Okay, so the first thing that we would do is we would go ahead and we would model our first equation, which is going to be the 2x squared plus 3. Now our second one is just going to be x squared, okay, plus we have 2x's and then we have a plus 5. So we need 5 of our tiles, and these are all positive. Okay, so this would be our 2x squared, this would be our x squared plus 2x plus 5. Now to add these two quadratics together, all it is just a matter of adding all of the like tiles. So we could put our 3x squareds together. We could put our 2x's because there were no x's in the first one. And then we just add up all of our 1's. Okay? And then after you have the student combine all of the tiles into their groups, going from x squared down to your x's and down to your 1's, then you just have them rewrite it. So we would say that 2x squared plus 3 plus x squared plus 2x plus 5 is equal to 3x squared plus 2x plus 8, because we have 8 1's. Okay? Now, we can do multiplication with these as well. So let's say we had 2 times x squared plus 3x and plus 1. Okay? So what we would do is we would put our x squared our 3x and our 1, and then a second group of 2x, or excuse me, x squared plus 3x and plus 1. So really what this is telling us is that I have 2 groups of x squared plus 3x plus 1, and that's what each of my groups is. So to multiply, all we do is just combine our groups. That would be my 2x squareds. This would now become 6x's. And as far as my 1's, I would have 2. So I could rewrite this as 2x squared plus 6x plus 2. Okay? We can also do division using a similar method. So let's clear the board. And let's say I have 3x squared okay, so we have 3x squared plus 9x and let's say plus 6. Okay, so what we're starting with is 3x squared plus 9x plus 6, and what we want to do is divide this by 3. Okay, so again, this tells the students that they have to break this into 3 equal groups. So we have 3 of these x squareds. Okay, so I'm going to break those into groups. Because I have 9 x's if they start to separate these, they're going to see that they could put 3 of those into each group. And to divide these evenly, they're going to have 2 of those in each group. So I took 3x squared plus 9x plus 6 and divided it by 3. And then all they have to do is, now that it's in 3 equal groups, count what is in one of the groups. So this would be equal to x squared plus 3x plus 2. Okay, now we're going to look at a couple of examples of solving for one unknown in linear equations. So what I have is 3x plus 4, modeled on this side, is equal to 4x, and this should have one more, minus 5. Okay, so 3x plus 4 is equal to 4x minus 5, and ask the students to solve, because what we're looking for at the end is just x is equal to what? Okay, x is going to have to be equal to some number. Alright, now the way that this works, and the way that I teach the students, is that you can move things back and forth from one side of the equal sign to the other, but when you flip it to the other side, you actually have to flip the number, or in this case, flip the tile, or flip the sign is what we're really doing. We always want to try and get the x's positive and alone, if possible. Okay, so the easiest way to do that is to see which side has the most x's first, and clearly this side does. So what I would do is I would move my x's over and flip them when they go to the other side. Okay, now if we move the x's over to the right side, we have to move our numbers, our ones, over to the left side. So these would go over here, and they would flip when they go over. Okay, now earlier we talked about that when you pair up like things that are positive and negative, what they do is they go to 0. And so we can take away that because that's 0, and that set because that's 0, and this set because this is 0. And we achieved our goal in that we have 1x with a number on the other side. So in answer to our question of what is x if 3x plus 4 is equal to 4x minus 5, we can now say that x is equal to 9. Okay, and for our last one on this video, we're going to solve for x between these two linear equations, where 2x minus 7 is equal to 4x minus 13. Okay, so again, the goal is to keep the x, or get the x, positive and alone. Okay, but right now we see we have 2x's here and 4x's here. So even if I move these over or subtract these 2x's, I'm still going to have a couple, but that's okay, they'll be positive. So I move these over to the other side, and they become negative. Okay, and because I moved my x's to the right in this case, what I'm going to do is move my 1's over to the left, but now all of these are going to become positive. So let's kind of separate some of these here, since some of these are going to be going to 0. Okay, so we can already see that we're going to have some left over. They're not all canceling, of course. Okay? And at this point, all of your zeros you would get rid of. So we have zeros there, we have zeros there, and we have zeros there. Now, right now we have 2x over here, but we have 6 over here. And what we need is our x by ourselves, or by themselves. So if we take a look at it, we have 2 x's, and so I could separate these 2 x's into 2 groups, which means that I would separate the left side into 2 groups. Okay? What I want to do is I just want to solve for 1x. So since each of these is equal to 3, I can say 1x is going to be equal to 3.